Hi, welcome to 3.3, Truth Tables for Conditional and Biconditional Statements. So for a conditional statement that's an if P then Q, you go with your true, true, false, false, true, false, true, false. Now a conditional statement is true for every case except when the antecedent, the first part's true, and the consequent is false. So if true then true is true, if true then false is false, if false then true is true, if false then false is true. So this is like saying to my kid, if you clean your room, I'll buy you a Nerf gun. So if he cleans his room, I give him a Nerf gun, I told the truth. If he cleans his room, I did not get him a Nerf gun, then I've lied. If he doesn't clean his room, but I got him a Nerf gun, I didn't lie. There's no proof of a lie. The only proof is here, when he fulfilled the first part. If he doesn't clean his room and doesn't get the gun, the Nerf gun, then I still haven't lied. Still a true statement. To prove it false, you must fulfill the first part, but not the second part. So the antecedent must be fulfilled with the consequent not being filled. So it says construct a truth table for if P then not Q. So to our P, our Q, are not Q, then if P then not Q. True, true, false, false. True, false, true, false. The negation of Q is false, true, false, true. Now we're doing if true then false, that would be the false statement. If true then true, that's a true statement. If false then false, that's still a true statement. If false then true, still a true statement. The only false statements when the first part is fulfilled, but the second part is not. The antecedent is fulfilled, but the consequent is not. Next one says construct a truth table for not R or not Q. So I should say if not R or not Q, then P. So we'll have to have a column for not R, not Q, not R or not Q. Then if not R or not Q, then P. So we'll go true, 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 false, 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 false. True, true, false, false, true, true, false, false. True, false, true, false, true, false, true, false. So the negation of R would be false, true, false, true, which is the negation of this column, the negation, excuse me, false, true, false, true. And the negation of Q, the negation for this column, the opposite of these values, false, false, true, true, false, false, true, true. Now we're going to do an or, a disjunction between these two columns. The disjunction is true as long as one of them is true. False or false is false. True or false is true. False or true is true. True or true is true. False or false is false. True or false is true. False or true is true. True or true is true. So this would be our if part now. If this, and the P is the then part. So it's going to be kind of weird to go backwards like this. But here we go. If false then true, that's a true statement. If true then true, that's a true statement. If true then true, that's a true statement. If true then true, that's a true statement. If false then false, that's still a true statement. But if true then false, that's a false statement because it fulfilled the first part, the antecedent, did not fulfill the second part. If true then false, that's a false statement. Or, yeah, that's true. I got that right. Okay, if true then false again, a false statement. So the false occurs when the antecedent, the first part, is true and the second part is false. I know it's awkward going to the left like that and creating this column though. Okay, I'm going to move on. Feel free to pause if you need to. Example 3 says, construct a truth table for if I drink a glass of water, then I will have a better complexion and I will sleep better. So P would be, I drink a glass of water. Q would be, I will have a better complexion. And R is going to be, I will sleep better. So our statement is, if P, then Q and R. So we'll go our Q and R here. If P, then Q and R. So true, 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 false, 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 true, true, false, false, true, true, false, false, true, false, true, false, true, false, true, false. Q and R, this is true and they're both true. So true and true is true. True and false is false. False and true is false. False and false is false. True and true is true. True and false is false. False and true is false. False and false is false. So this is the if part. This is the then part. If T, then T, that's true. If true, then true is true. If true, then false, that's false. If true, then false, that's false. And if true, then false, that's false. Now, the rest of these P's, the rest of the if parts are all false. So it doesn't matter what these are going to be, they're all going to be true. If false, then true is true. If false, then false is true. If false, then false is true. If false, then false is true. Now biconditional, this is the double arrow. This is P if and only if Q, which means if P then Q and if Q then P. So it's going both ways. This is true if they're the same thing. That is, if true if and only if true is true, but true if and only if false is false, false if and only if true is false, and false if and only if false is true. So they're the same thing. They have to both be true or both be false. So for example 4, oh look at that, that lined up nicely. Okay, so we have Q if and only if R and P, so we're going to have an R and P column. It's like wrap. Then Q if and only if R and P. So R and P, it's true if they're both true. True and true is true. True and false is false. True and true is true. True and false is false. Yeah, that's right. And then false and true is false, 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 because the rest of these, the P is all false. Now it's a double negative, or it's a biconditional. They have to be the same. True if and only if true is true. True if and only if false is false. False if and only if true is false. But false if and only if false is true. True if and only if false is false. True if and only if false is false. But false if and only if false is true. And false if and only if false is true. And there's our statement. So and then we are comparing this column here and this column here to give us that column. Okay, let's go on to the next one. So feel free to pause if you need to. So let's determine the truth values if P is true, Q is false, and R is true. Let me fill this in again. True, 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 true. False, 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 false. True, true, false, false. True, true, false, false. True, false, true, false, true, false, true, false. So we're looking at the case where P is true, Q is false, and R is true. So we're looking at P being true, one of these four, Q being false, so one of these two, R being true. So we're looking at this row. Then we have not P. We have Q or R. So then we have if not P, then Q or R. So this would be false, 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 false. I'm just negating the P. True, 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 true. Q or R. Just one of them has to be true. True or true is true. True or false is true. False or true is true. False or false is false. True or true is true. True or false is true. False or true is true. False or false is false. So now we're going to be doing the double negative between these two columns. They have to be the same. False if and only if true is false. False if and only if true is false. False if and only if true is false. False if and only if false is true. True if and only if true is true. True if and only if true is true. True if and only if true is true. And true if and only if false is false. So the specific case they want us to find out is this one here. And the result is false. That's a false statement. I'm going to scroll up, so feel free to pause if you need some more time there. So we can get this to line up. Not quite. Look at that. Okay, that works out. No, I can't read the question though. Okay, we'll just erase the whole thing and fill in the chart again. It says determine the truth value for each simple statement, then using the truth values determine the truth value of the compound statement, excuse me. So we're going to have true, 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 false, 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 true, true, false, false, true, true, false, false, true, false, true, false, true, false, true, false. So our statement says if 3 is less than 1, and that part is true, and 7/8 is greater than 1, that's not true, that's false. Then 15 over 16 is less than 1, that's true. So this is our P will be 3/4 less than 1. Our Q will be 7/8 greater than 1, and our R will be 15/16 less than 1. So what we have here is if, let's do this, P and R. If P and R, then if P and Q, then R. So if P and Q, then R. So we're going to have our P and Q column, then our P and Q, if P and Q, then R. We don't need this last column, so that's unnecessary. So P and Q, true if they're both true. True and true, true. True and true, true. True and false, false. True and false, false. And for the rest of these, the P part's false. So they're all going to be false, false, and true, false, false, and true, false, false, and false, 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 and false, false. So this is the if part here, and here's the then part. If true, here's our if, here's the then. If true, then true is true. If true, then false is false. Now the rest of these, the if part's false, so it doesn't matter about the then part. If false, then true is true, 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 and true. They're all true. So the specific case had P being true, Q being false, and R being true. So true, false, true. Looks like we're right about here. And in this case, we have a true statement. Okay, so pause this if you need to pause it. I will go on to the next page, or the next topic, I should say. Self-contradiction would be a compound statement that is always false. A statement that is always false. So example 7 says, construct a truth table. We have P if and only if not Q, and P if and only if Q. This is true, true, false, false. True, false, true, false. Okay, so we have not Q in here. Then we'll do our P if and only if Q. P if and only if, I did not Q first. P if and only if not Q. P if and only if Q. And then we'll do P if and only if Q. And, it's a not Q first. I keep doing the wrong one. P if and only if not Q. And P if and only if Q. So the negation of Q would be false, true, false, true. P if and only if not Q. So we're looking at them being the same. True if and only if false is false, but true if and only if true is true. False if and only if false is true, and false if and only if true is false. Now we're going to be looking at the P if and only if Q, these two. True if and only if true is true. True if and only if false is false. False if and only if true is false. And false if and only if false is true. So the last column compares these two here with an and. False and true is false. True and false is false. True and false is false. False and true is false. The point is this statement is always false. So this is a self-contradiction. So that's a self-contradiction. It's always false. A tautology is a compound statement that's always true. So here we have P and Q. If P and Q, then P or R. Can you guess what this one's going to be in the end? True, 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 true. False, 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 false. True, true, false, false. True, true, false, false. True, false, true, false. True, false, true, false. P and Q. It's the and here. True and true is true. True and true is true. True and false is false. True and false is false. False and true is false. False and true is false. False and false is false. False and false is false. So, and again, knowing P is false for these 4 in a row, you could just say they're going to be false there. Now it's P or R, these two columns. Just one of them has to be true. True or true is true. True or false is still true. True or true is true. True or false is true. False or true is true. False or false is false. False or true is true. False or false is false. Now it's an if-then between these two. If true, then true is true. If true, then true is true. If false, 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 then false is true. If false, then true is true. If false, then false is true. So the only case I can make it false is if the first part was true and the second part was false. We didn't have any of those situations. So this is an example of a tautology. It's always going to be a true statement. I'm going to move on, so feel free to pause if you need to. The last concept is that of an implication. And that is a conditional statement that is a tautology. So what we just saw in the last one was an implication because it was a conditional statement. So all implications are tautologies, but not all tautologies are implications. So is the following an implication? Q and P and Q. If Q and P and Q, then P. So we'll do our P, our Q, we'll do our Q and P, our Q and P and Q, then our Q and P and Q, if that, then the P. True and true is true, true and false is false, false and true is false, false and false is false. This column, comparing these two. True and true is true, false and false is false, false, false and false is false. Now we're going to do the conditional. Here's our if part, and here's the then part. If true, then true is true. If false, then true is true. If false, then false is still true, and if false, then false is true. So this is an implication because it's a conditional statement. And that'll do it for section 3.3. Some of your questions. Thanks.